Okay, Virendra, let's proceed ahead with your mock, and we started with your very brief introduction.
Sir, sir, I am Virendra, sir. I belongs to a place called Chandigarh, sir. And my father was in army. My mother is a homemaker, sir. I did my class 10th. I am a Kendra Vidyalaya student. I did my class 10th from Hyderabad, and I had scored some 88%. Followed by that, class 12th with medical and non-medical, that is maths and biology both, wherein I had scored some 92%. Followed by that, I had cracked UPSC, and wherein All India ranked 7th I had scored, and then joined NDA, National Defense Academy. I got a degree of BSc Chemistry honors from there, and followed by that, I got one diploma from Indian Military Academy. And I got an opportunity to do a mechanical engineering, and I am holding a degree of JNU for this mechanical engineering. The project which I did in my mechanical engineering was central tire inflation system. It was based upon the requirement of my department, and based upon various terrain requirement. And followed by that, I have also done 3 other diplomas, and I'm known to one foreign language as well.
Okay, so Virendra, what what motivates you to join this particular course?
Sir, this is one of the good career options, sir, wherein I can, by doing this course, I can improve, I can do good in my career and further, sir. And secondly, sir, flying, doing this in aerospace engineering or aerodynamics, the flying things are something like which are always like fascinating sort of thing. So that's why the aim is to do something in this aviation field, sir. So that's why I'm doing.
Okay, so why you're choosing this design stream?
Aerodynamics, sir. Sir, these are, first of all, these seats have been given by our ministry, sir. And secondly, I also want to do this because being a mechanical engineer, sir, I think the aerodynamics is the best one which I can do.
So, Virendra, how do you define aerodynamics?
Sir, aerodynamics, aero means, sir, something which is related to air, sir, and dynamics which is something like changing. So if the flow of air, I'll say that it is aerodynamic. The changing flow of air, the study of flow of air is called aerodynamics.
Okay. So what is the dynamics means in this?
Sir, dynamics will also include the reason why they are flowing. The air is flowing. Something like why this air are flowing, like which all sorts of forces are acting on this. That will, I'll say, is the dynamics.
So now suppose I give you a flowing air, and there is a if I give you a particular body which is there, so there are different kind of forces acting on the body because of the flow of air. One can be lift force, another can be drag force. Can you define how these forces are? Yeah.
Sir, may I please know if you're asking about aerodynamic forces, sir?
Yeah, I'm talking about the forces applied by the flowing air on the body.
Sir, the various forces which have been applied by flowing air, there will be some sort of pressure forces, sir. And if I talk about the aerodynamic forces, then there will be lift force, some drag force. There will be certain thrust which will be produced by engine, and the weight of the body which is acting downwards. So these are all sort of aerodynamic forces, sir. But specifically, if I talk about air, then it will be pressure force which will be applied on a flying objects.
Are you aware about drag coefficient, lift coefficient, and all?
Yes, sir, I am aware about that, sir. Drag force, sir, drag force is something which is preventing the flying object to move forward. It is resistance. I'll say that it is a fluid sort of friction. That the friction which is offered by air, so that which is preventing the body to move forward. So drag force is given as if I write drag will be equal to coefficient of drag into dynamic pressure into shape of the body. So drag coefficient will be equal to drag force divided by dynamic pressure and shape of the body. So it will depend mostly upon the aerodynamic structure or aerodynamic shape of the body.
I'm giving you this diagram, Virendra. Can you see this?
Yes, sir, I can.
There's a body which is kept at an angle theta with horizontal.
Yes, sir.
And air is flowing in the horizontal direction.
Sir.
You have to tell me how the drag and lift forces on this body will change with theta.
Right, sir. Right, sir. Shall I share this whiteboard thing, sir?
Yeah, that will be wonderful if you could do that. If you can explain that on the board.
Sir, may I please know if it is visible, sir?
Yeah, it is visible. Yes, you can see that.
Sir, you are telling that these are the.
This is a horizontal direction of airflow.
Sir.
And take, yeah, no, this is the body, inclined body at an angle theta.
It is inclined at angle theta, and this is whenever this body stream will be hitting, then it will be flowing something like this, sir. It will go like this, sir. So if the forces which are going, these are the streamlines, sir, which they will be flowing like something like this, sir.
Don't forget to see that air is flowing over a broad region. Even the body is in between the flowing air, horizontal flowing air.
Yes, sir.
So air is flowing above the body also, below the body also.
Yes, sir. Yes, sir. So these will be something. These will be some streamlines, sir.
Yeah.
I assume that far away the pressure is something like pressure P atmosphere, sir. And here it will be P atmosphere. And whenever the body is flying, sir, over here, I'll say coefficient of pressure. Sir, the pressure over here, sir, because of the shape of the body, the pressure at the upper surface will tend to decrease, sir. This pressure will decrease, sir. There will be more negative coefficient over here.
What will be happening? What will be happening in the shadow region of the body?
Over here, sir.
Yeah, I can't see where you are marking.
Sir.
In the shadow region, you know that wedge.
Here, sir.
So here, I'm sorry, it is not. No, just above that shadow region.
Here, sir. Here.
No, that is the below part. I'm saying the wedge region, the region which actually I'm talking about this region. This region I'm talking about.
Sir, inside, sir.
Yeah. The body. This is a horizontal part only. This is not the body.
Sir.
The horizontal line we have drawn.
Sir,
the body is only this. This is the only body. This one. Plate. Inclined plate.
Sir, pressure will be decreasing over there. Behind, sir, there will be pressure will be decreasing because velocity of the particles will be low, and ahead of it, since the velocity of particle is more, correction, sir, velocity of the particles are more ahead, then means pressure will be low ahead, and behind the pressure will be more because velocity of the particle is less. If I apply the Bernoulli principle over there, sir, then I think it will tend to flow from high pressure to low pressure, and that is from inside to outside air will be flowing, sir.
Okay, Virender, if I am designing aeroplane for high lift coefficient,
sir,
my first question is, should we design it for high lift coefficient or high drag coefficient?
Sir, high lift or high drag coefficient, sir. Sir, high lift coefficient we should be designing, sir. Then only I'll be getting more amount of lift, which is desired, sir. I do not want drag, sir.
But the trouble is, aeroplane is not to only lift; it is to land also.
Yes, sir.
What happens when it is to land? What happens to then the high lift coefficient which you have designed it for?
Sir, if it is in case it is land alpha, the way my angle of attack is changing. So, in order to decrease that angle coefficient of lift at that time, I will put my flow will be converted from my flow separation will take place, and my lift coefficient will change accordingly. So I can attach some sort of secondary devices, but desirable will be high coefficient of lift itself.
I'm giving you another diagram, Virender. Can you see this diagram here?
Sir, is it something like?
Maybe you can remove this your board and then it will be visible. Maybe the diagram will be a little more visible to you. There's a liquid jet actually which is impinged upon the stationary inclined flat plate. You can see liquid jet.
Yes, sir. Okay, sir.
So liquid jet is impinged on the inclined straight plate, inclined stationary plate, flat plate. So some discharge Q1 goes in one direction, Q2 goes in another direction.
Yes, sir.
I don't want you to make a detailed analysis of that, but I simply want you to tell me what factor decides Q1 will be going in this direction, Q2 will be going in this direction.
Q1 is discharge, sir. Sir, I think the inclination of this plate, sir, that will with respect that will depend whether the Q1 is going upward or not, sir, and also the velocity factor, sir. Well, discharge is equal to area into velocity, and the velocity, how much velocity it is, and the inclination factor, sir.
Do you think velocity will be same both sides?
Velocity will be same, sir. If I ignore the gravity factor, sir, then the velocity will be same over both sides. But area is same and at both the same.
We are not even bothered about area actually.
Sir, it will depend upon the theta angle, sir. With this nozzle is inclined to this plate, sir.
Obviously, it will depend upon theta. But I was looking for answer in terms of some kind of resistance.
Sir, some kind of resistance, sir.
When the liquid hits at that spot, so
yes,
how it is decided that Q1 will go this side, Q2 will go this side or something?
Sir, I don't know, sir.
Okay, over to you, Virendra sir.
Good afternoon, sir.
Okay, so your name is Veer Singh or Varinder Singh? What is the name?
It's Veer, sir.
Veer, okay.
Yes.
Okay, so Veer, you are appearing for this IIT Bombay Aerospace, right?
Aerospace engineering and aerodynamics, to be precise, sir. Aerodynamics.
So, have you given any kind of preferences or what? So you have received a call only from aerodynamics, or you have given some kind of preference?
No, sir. These are the sponsored seats, so it is only one seat and one interview, and it's aerodynamics.
Okay, it is aerodynamics only. So okay, so when we say aerodynamics, so what do you understand by aerodynamic body?
Sir, aerodynamic body, sir, something like if I take an example of a fighter jet or something like the racer car, sir, their shape is designed accordingly so that they offer minimum resistance to their flow or their travel, sir. So if air is getting minimum resistance when it is flowing over the surface of something, then I'll say that the shape is aerodynamically perfect, sir. So aerodynamics is, as I already told, sir, it is flow of air, and so my bodies are designed accordingly, sir. Aerodynamically designing of the body, sir.
Okay, so by designing, basically what you are doing, by giving a aerodynamic shape, what you are basically doing, what
Sir,
objective you want to fulfill?
It will depend upon my purpose, sir. If it is something like a car, then I will design that shape differently, and if it is a flying object, then my desire will be that I should get the maximum amount of lift. If I am designing a car, sir, then my objective will be that there should be minimum amount of drag, sir. So it will depend upon the purpose for which the object has been designed, sir.
So okay, so let us say you are having kind of a spacecraft, right?
Yes, sir.
So when spacecraft enters the Earth's atmosphere,
yes, sir,
what kind of resistance it is? It basically gets. You have a spacecraft,
yes, sir.
So which is entering the Earth's atmosphere.
Sir, first of all, outside Earth's atmosphere, they won't be like for these bodies to flow, sir. Then the first and foremost thing which will be required is an atmosphere, that the gases should flow over its surface, sir. If a spacecraft is entering into Earth's surface, then it will get lot of resistance and lot of drag force because of presence of atmosphere, sir. And the particles which are present in the atmosphere, they will be if I say that drag, there will be something like a spin friction drag. I have, sir, drag due to flow separation, induced drag, and there will be some wave drag, sir. So spin friction drag I will be getting because of the friction present, because of friction on this aerodynamic surface, sir. And there will be some sort of flow separation. And flow separation, since this spacecraft is coming out from outer surface to inside, I assume that the speed is also supersonic. Then there will be some sort of wave drag also in this, and also there will be some component of induced drag because of the vortices and downwash which has been produced. And I think these the drag will increase, sir, if it enter into
So, so almost you told me almost all the harmful effects that we could kind of face over there, right?
Yes, sir.
So
Yes,
how to
sir.
avoid? So how to we can how we can make the design changes so that we can take care of these,
Sir,
like in friction diagram, you are having a flow separation and all that.
Sir, in order to avoid this spin friction drag, sir, I will prefer a laminar sort of flow on my this aerofoil, sir. And laminar flow is possible when my angle of attack is something like low angle of attack. And in order to avoid this flow separation, then I prefer a turbulent sort of flow, sir. Because turbulent flow, there will be flow will be attached to the surface till for the time more than that of laminar flow. So I'll attach some sort of spoiler or some sort of suction device. I can ensure this turbulent boundary, sir. Since I cannot have laminar or turbulent boundary, sir, I'll have some surface which is thin, which is having a laminar sort of flow, but I'll attach some secondary device which so that I can get a turbulent flow in the end, sir, in the at the trailing edge of the aerofoil, sir. And in order to reduce this wave drag, sir, I'll ensure that my shape is designed supercritical airfoil so that drag divergence Mach number will be near to m is equal to 1, like near to supersonic speed, sir, sonic speed. So this I can do, sir. I'll design the aerofoil. My conclusion is aerofoil I'll be designing in a supercritical aerofoil I'll be using, sir.
So, you know, we have a aerofoil section of the aircraft wing, right?
Yes, sir.
So how this aerofoil section generates lift?
Sir, generation of lift, sir. Sir, the first and foremost thing for generation of lift is an atmosphere, and the flow of gases should be ensured over the surface. And secondly, for it is a combination of various aerodynamic forces which produce lift, sir. The combination of because of the aerodynamic forces will be produced because of the pressure distribution over the surface and because of shear self distribution over the surface. For producing lift, sir, it will be the requirement of distribution of pressure, sir. It can be explained with the help of two principles, sir. If sir, if I may draw with your permission, sir. Can I use this whiteboard, sir?
Yes, go ahead.
Sir, if I draw, sir, if this is my aerofoil, sir, if I draw this aerofoil and these are the streamlines, sir. So the first principle which I'll be explaining is Newton's third law. Newton's third law, sir. Newton's third law, because of this aerodynamic shape, sir, the flow is getting drifted somewhat downward, sir. Somewhat downward. It is getting drifted somewhat downward. So there is a downward movement of the momentum and downward movement of kinetic energy. So according to Newton's third law, opposite and equal force will be applied, and this it will produce some upward lift, sir. This basically Newton's third law is applied because of pressure distribution itself. The second is the Bernoulli principle, sir. Bernoulli principle, in which if I take these two sections along this streamline, sir, these two sections along a streamline, then if I may draw lot many streamlines, the pressure at far end will be P atmospheres at the normal pressure, and this below also there are lot many streamlines which are flowing, sir. If I apply this Bernoulli principle on this upper layer, sir, the pressure here, sir, here it is more. Similarly, on the second layer, pressure here will be less and compared to this. So pressure, if I draw this downward component, pressure is decreasing. Similarly, if I apply Bernoulli principle on these streamlines, pressure is increasing, sir, over here. So there is a difference of pressure over and above, below and upper surface and the lower surface of the airfoil, and this distribution will produce me an upward lift. And because of distribution of pressure, different pressure at upper and lower surface, the lift is getting produced, sir.
Okay, have you heard about cavitation?
Yes, sir, I have heard about cavitation, sir. Sir, so, cavitation, sir.
Go ahead. Go ahead.
Sir, if I'm putting some water inside a vessel, sir, And because of I'm sitting at this atmosphere, some one atmosphere is pressure over here. The pressure is hitting like a pressure. It is pressing that liquid, sir. And then I start heating, the internal energy of that thing will start increasing, sir, those water or something, sir. Then the bubbles will start increasing. When the pressure will become more than that of the atmosphere, it will start vaporizing. So if I am making them to hit some surface, something like a turbine or something, sir, then there will be some sort of pressurized bubbles which will be produced. If this pressurized bubble, they are moving from one place to another place, pressure here was more, pressure here is less, they will tend to burst, sir. Those amount of thousand amount of bubbles which are bursting, they will produce an incredible amount of pressure. Their bursting force they will be producing. So it will lead to erosion of that surface. So erosion of this surface, I will say it is a cavitation, sir. Because of this high pressure bubbles.
Is there any chance of cavitation at the end of aerofoil section?
Sir, at the end of airfoil surface, cavitation, sir, I don't think that there will be any cavitation in the end, because I think in the end that is the trailing edge, then there will be some sort of flow separation. I don't think that the this particle will be hitting there, sir. There will be some flow separation over there.
Okay. Okay, Veer, I think now we can give you the feedback, right?
Sir.
So I think, okay, so from my side, I think it seems okay. You are able to explain the concepts properly. So I think you may have, you're from, okay, so you're from mechanical background, right? Now you're working, right?
Mechanical.
Okay, so you're working in army or what?
Yes, sir, defense forces.
Okay. So I think you have good grasp on this area, whatever I discussed with you. So rest, the remaining part, mostly related to the other area. I think Dr. Vijender will give you the feedback right now. Just wait for a second, okay?
Sir. Sir, where should I, sir?
Yeah, Virender, you were asking something?
Sir, I'll ask later on, sir. It is not related to this. After feedback.
Okay, so that's it. I mean, the moment you say aerodynamics, they may ask you all the forces.
Yes, sir.
Various aerodynamic forces acting on the structures. Just Google it out and you will find something, some analysis. Lift force, drag force, those kind of things, you please find it out.
Yes, sir.
And how it changes and all.
Sir.
And fluid mechanics will be important subject for you for that.
Yes, sir.
So just revise that also, the kind of force acting on the structures, and later on it will be turbines and everything, related to that. So fluid impinging on some surface and how it goes. So those kind of things are important for you, Virender. So try to find out, revise that particular thing, and fluid mechanics is important subject, especially for the machinery part. Yeah.
In case they'll be asking that which subject I have prepared, I am going to say, sir, it's fluid mechanics and basic thermodynamics. Sir.
Okay, no issue. Sir. So, but then this question which I asked you were from fluid mechanics only.
Sir.
Lift, drag, and all the impinging forces and discharge going this way, that way. That all was fluid mechanics.
Sir.
In fact, the fluid dynamics part. After fluid dynamics comes fluid machinery.
Sir,
so the question which I asked.
Sir, fluid machinery, I haven't prepared, sir.
So this question were related to that.
Sir.
So dynamics ends up at starting of machinery.
Sir.
That is what you have to do. Right, Virender, when is your interview?
Sir, 9, sir. Like
2
days.
After 2 days you have 2 days. Just be calm, be confident, and be honest in the interview.
Yes, sir.
Okay, thank you.